Hello, my name is Ryan Tulloch, and I am the president of ProDelta Projects. First, I'd like to thank you for taking your time to join us on our webinar. We are a data management company that specializes in photogrammetry surveying and visualization of data. We do have a lot of experience in new pipeline construction and as well as historical experience with working in an oil and gas producer. We get the challenges that are facing new pipeline construction, from regulatory obligations, environmental conditions, obstacles such as steep hills and unstable terrain, access issues, landowner and First Nation concerns, asset logistical challenges, and data management. We took it upon ourselves and we saw a niche that we could build a very unique data management system that would specialize in the visualization of data, and as well as collecting multiple data. So to do this, we took two very basic concepts and developed a system. The two concepts are, the first thing is we only have one constant to work towards, and that is where something will happen or has happened. And the second is that the majority of people in this world are very visual. So with those two concepts, we took four principles to design our data management system. The first, the data must be very visual and easy to interpret. Anybody in the room should be able to see something in there. The data must be searchable and easy to find. With our search tools that we've developed, it's easy to search through data. We must be able to take and be able to store data from multiple sources. And we do not want our system to require a bunch of extra staff to run it. So what we've done is we've built a system that can go from estimation to grade planning to data management during construction to turnover package. So through our estimation stage, I'll go through this in more detail. We can generate a quick grade plan based on the engineering studies and previously completed by the owner. During the planning stage, we can complete a photogrammetry survey using both manned and unmanned aircraft. I'll talk about the advantages of both of these later on. We can identify key areas where it may hinder construction progress and give that as the primary focus of the contractor. Generate a detailed 3D plan of the entire right-of-way, including 3D objects such as valve sites, power lines, pipe, equipment, and rig mats to put in. Utilize mobile data management to collect data. The mobile data system, which we'll go through, can replicate existing forms, which include QA, QC, and environmental forms. Integrate weather into the system for the duration of the project. Integrate cameras that are placed at strategic locations on the right-of-way that can be used for security, time-lapse photography, as well as the project management team to do daily inspections on. Be able to take all this data and at the end of the project be able to export it into enterprise GIS system that the owner may or may not have. So I'm going to go through fairly quickly on how we can do our estimations. So I'm going to jump into a project. So this is very typical of what most clients use is a Google Earth type format. You bring in a KMZ file and you put it over the satellite imagery that's free. A couple things that make this challenging and not the best data source is you can't rely on data control throughout other groups. KMZ files are easy to share and they seem to get lots of revs get mixed up. Additionally, the imagery that you're going over is typically fairly poor resolution, even though this isn't too bad. This is still only 1 or 2 meters per pixel, and it's old. So in particular, you could be going anywhere from 2007 to 2017 imagery. So I've brought this in similar to you would. Additionally, we've brought in the master crossing list, which is all interactive. And like I said before, this is 3D, so we can just scroll around, look at everything in 3D. So we want to click on that. It gives us the details of this wetland. This is a treed fen, KP plus 974. It's got your crossing method and everything with that. So as we mentioned before, we've always wanted to make our data very searchable. So to do that, we can click on the attribute table of this. So we'll go ahead and click on the attribute table. So this is spread 1 crossing type watercourse equals class S3. So I'm going to go ahead and search that. On this particular spread we got 3 of those. So if I want to go take a look at one of those, see what's going on with that, and put a value to that based on what we have for available data. This gives the estimating team a very quick and easy way to start searching through this data and how it's going to affect them based on what they're going through. Additionally, on this particular project, the client actually had LiDAR data. So instead of trying to use a bunch of different software, we can actually bring the LiDAR data right into this interface. So when we do that, it's true LiDAR data, so we're down by the watercourse on this job. You can always take a quick query, measure that, or take a query of what your lat, long, and elevation is. There is simple tools in here as well, easy to use, such as distance tools. So it's like a ruler, you can click and verify any distance you want. One of the most powerful tools we have though is our slope query tool. So I'm going to go ahead and jump to a setup that I've set up at KP9. As you can see, the imagery does get blurry. That's based on the resolution pyramids. As we zoom in or let the computer render, it doesn't take much to do it. So what the slope query tool does is, along the right of way, we take a slope every 10 meters on each one of these lines. So when I go ahead and turn that on, I've already done it. You can see that all these slopes are been calculated. So green being 5.8, 11.3. We can actually set a color code to the range of it. So if we wanted to, for example, quickly show you how to do that, or how we do it. Slope value. As you can see, we've set the ranges up here on different things. So if we wanted to change the slope query, as you can see, these ones are orange here. If we wanted to change the value to that to, well, let's go cyan. Once we hit apply, you can see it happens very quickly. So the benefit of that is the estimating team can go through that. We can determine based on what we want to say is light, moderate, and heavy grade, and color code that to whatever colors you want. I typically use the red, yellow, green system. However, kind of going over LiDAR data isn't always the best because of the colors on the background, but that is an option. So the other option, great tool we do have built into this is our terrain profile. So if we were to just want to do a terrain profile on the ditch line, I'm going to show you how quickly that can be done. Select a group. So as you can tell, I'm going to do it on the ditch line on the first spread here. And this is your terrain profile. So you can scroll around here at any time and look at the data of what's going on. This is just using the terrain's based on the LiDAR data. And you can click on it at any one spot and it'll jump right to there. And you can move around up in the 3D world and see what's going on there. If you want to see where these really steep hills are and get a feel for them, that's what it looks like. Later on this year, we're actually going to build a pipe analysis tool on how we can modify this terrain and what our pipe bendings are going to look like. Not that we'd ever recommend pre-bending or anything like this, it just gives you an idea on how to plan for bending and production rates. The other options we have, it always depends on the client data, is in this particular data they had a geotechnical study completed in which they developed a soil terrain map. So I'm going to go ahead and turn that on and show you how well that looks. This is just based on the geotechnical report. And this all corresponds to it, but it does give you a better understanding of what type of material you'll be having to complete grade on and other things like that. And it's very interactive. You click on it, it gives details of what goes through there, and it depends on the shapefile format and what attributes we can bring into that. So that is a quick overview of what our estimating does. Like I said, this is very quick, just helps prioritize some of the stuff for your estimating team to work through. We complete a lot of photogrammetry surveys for both owners and contractors. The benefit of the photogrammetry survey is that it's an actual up-to-date, high-resolution concept of what the project's going to be built through. Between timbers, cruises, wetlands, environmental concerns, landowner concerns, it is all actual up-to-date data. We use both UAVs and manned aircraft. The UAV limitations being Transport Canada. Visual line of sight must be kept at all times, so that's usually about 500 meters away before you lose sight of it. And additionally, we need to have landowner permission before we take before we can land on or off their property. We found that actually using a manned aircraft, which we utilize the Jet Ranger helicopter for all of our flights, is actually the most economical way of doing it. Typical 26 or 30 kilometer pipeline can be done in about an hour and a half to 2 hours of flying, depending on location from the nearest airport and fuel. Based on that, we can get between around 5 centimeter per pixel resolution and generate that into a 3D model. I'm going to go through this in a bit more detail and how we've integrated that into our 3D model. So here's a project that we completed a photogrammetry survey on. So as you can see, this is the free data that was available. So we zoom in. We have a creek crossing here. It's an S2. As you can tell, it's hard to see what's going on there. So we'll go ahead and turn on our orthomosaic. And you get a very clear understanding of what the challenges are to do with this. You got a lot more rock to deal with, which could take extra time with equipment. The revetment of this creek might take quite a bit longer, as you're going to be dealing with rock, sandier conditions. And additionally, we can have you can start measuring simple distances to get a better understanding. So an analysis would be this: 16.56 meters. The other advantage of this orthomosaic is we do have an RPF on contract as needed, is we can actually calculate the timber volumes of this using government data and our own polygons that we generate from this. The benefit of this is we can get a more accurate timber volume for production rates and for cost estimating. And additionally, as the federal government is transitioning to carbon footprint, we can utilize software that can actually calculate our carbon footprint and what it would take to offset that carbon footprint. If you have any questions in regards to the carbon footprint, please feel free to contact us at any time. However, now we can go into, an orthomosaic is nice, but again, it's only 2D and the world is in 3D. So we're going to go ahead and show what the 3D mesh looks like at that same spot. So now we're in 3D world. As you can get, we do have a bunch of trees in front of us. We can calculate average height. The mesh, it is a 3D mesh, so it isn't as great because we are using a camera, but it does give a good representation of what we're going through. And this is only going to get better with time as new software and new our developers are developing new software all the time. So now we have a 3D mesh. The other nice thing we can do is we can actually do a virtual fly-through on the video. We can export this into just an MP4 format, which can actually be used as part of the safety orientation or construction orientation to the client or to the contractor. This is done fairly quickly. Within a couple hours we can generate a presentation. We can also put a presentation where it can stop and start. The other nice feature is we can drop in 3D objects, so very quickly and easily. So here's an example of where we could drop an excavator in. For some reason that didn't snap to the proper spot, but that's easy to fix. It's sitting there. And this is all to-scale equipment. And with anything else, attaching points with PDFs such as borehole logs for geotechnical studies, anything like that can be incorporated into our model. So I'm not going to spend too much more time on this, as I know we have lots to go through and we want to talk more about the data and management side. So I want to get to that here next. Alright, now that the project has been awarded and planned, it is time to execute the project. One of the key systems we have embedded into our system is the ability to handle data collected from a mobile platform. We've utilized a platform developed by our friends at Nmap. The benefit of this system is that it works with both Android and iOS platforms. It is a very simple interface to use. If a user can text, they can use our interface. It works offline, so cellular service isn't always required, and when it can also be integrated into a higher level GPS such as an RTK system. We're able to adapt the system to replicate existing forms, so you don't have to change your business on how to use our system. And on top of it, we can export both into our interface as well as into a PDF form. So I'm going to go ahead and show you how simple this is to use. Right, so here's an example of how the mobile data interface works. So I've gone ahead and opened it up. I just showed you multiple projects assigned to one tablet. All forms are assigned to a project. Here's a list of forms that we have on this specific project. And we're just going to do a quick daily and comment form. So as you can see, all these fields that can be filled in are now searchable fields. So if we had drop-down menus of whatever conditions you wanted to say, those become searchable fields that are easy to search, and then therefore analytics can be done on it. Again, these data can be searched, but it's going to take a little longer because we've got more variables into it. On this day, I'm looking at an erosion on it, which you'll see here shortly when I take a photo. So now as I open up the tablet photo, it's as simple as add image. You're going to say take a photo. And there's the camera. So now you're standing as if I was right there. Use photo is all we're going to click. If you wanted to, you could take 2 or 3. We can also make the daily photos a mandatory part of it. So that's a good thing to do to ensure that people are collecting it, and then you have a good record of conditions. And as always, we embed the signature into it. So we sign it, we hit save, and that's it. Now we've saved the form. On the top left button, we just have to hit the green circle, and we would start syncing. As you've seen before, how quickly and easily it is to generate a mobile data inspection. As every field is filled out, those become searchable fields. A lot of the data is generated from the tablet, such as your GPS and time. So your inspection and worker team syncs to the data of the database, and I'll show you how we import it into our management system. So I've done this. It took literally minutes to do, and it doesn't matter how many forms it is. It's just a matter of organizing them on our end. So we bring it in. So here's our daily inspection that we just took. As I showed you before, here's all the fields I filled in the field. And additionally, we imported the photos. So now, for a record of conditions or any inspection that you want to have a searchable data for, this is all organized by date, and it's automatically organized by KP longitude. So now you can just click on this, and it opens up the photo. This is a direct link, and of course this is exportable data. Additionally, we want to make this all searchable, or reportable. So what we've done is we've created a very nice looking spill report form. So this is an example of a form we've done for Spectre Enbridge as a demo. Again, a lot of this data is filled in automatically. And as you go down, these are all fields that we've just built the template for. And it doesn't matter if it's one form or 50 forms or even 1,000 forms. Once their script is developed that we do internally, it takes literally a field administrator minutes to export this in. Of course, we have the signature so we know who did it, and then we can embed photos. As I mentioned, this was a demo, so I just took some photos around my tablet, which includes us out working in the field with side-by-side and just a picture of one of my field backpacks. So the benefit again of the mobile data is there's no more paper, no more hours of searching through data. We quickly bring it into our system. It's visual, it's easy to search. So as we mentioned before, we wanted to make this data very easy to use and for any user to do. So here we've turned on weld mapping that we did with Nmap. So here all these red pins are weld maps, so we can change the logo to whatever the client specifically wants. And when we click on it, here's all the details of that weld, from date that it was welded to who did it. So again, this is all searchable data, so if we just go search, we can search for any of this data here. And again, with over 1,000 welds, it took about 20 minutes to import all this data into here. And that is how quickly and easily we can do this data because of the system we've set up. Alright, sometimes we have clients that want an aerial inspection done of their project as a bit of a construction progress monitoring. This helps with any claims and just to see where everything is, especially on larger projects. So what we do is we usually use a helicopter again because it's quick and economical. And we capture photos at a timed interval as well as video. So this is an example of how we embed the photos into our system. So each one of those icons represents a photo, and again when you click on it, it's just a matter of opening it up and it opens up the photo that we took. We usually fly fairly low, so the resolution's good. And additionally, as these photos are always date and time stamped, again, that's a good record of conditions for any regulatory inspections or concerns that may come up. We can also embed video, and I'll show you that in a bit later. In addition to collecting photos while we do the aerial inspection, we also do georeferenced video. We can embed that into the GIS system, or we can do it as a simple standalone MP4 video that can be played on any Windows media player. As you can see here, we have lat long tracking, approximate KP, and your KP tracker along the right-of-way. As mentioned before, we also have mobile or temporary cameras that can be installed on the right-of-way. So here's an example of one of our security/camera trailers here. This is a 3D model we've built. Very simple. That's basically what it looks like, except we have more cameras and solar panels. They're all self-contained, self-powered, so no external power required. So we can do a couple analysis based on where we want to put these. As we can model everything, we can actually do a view shed of what can be seen. So we'll go ahead and do that. As you can see, the green indicates areas that can be seen easily based on the focal length of the camera. These can be done to kind of determine predetermined spots of the best location for security personnel. In addition to the security, which I'll show you here in a second, it's all embedded into it. So I simply just click on it, and it's going to open up a camera we have sitting in Hamilton, Ontario right now. And when I hit play, you get the live feed of the camera. So one of the best uses for this is for construction managers to check critical spots along the right-of-way of different conditions as they change. Our back-end security features offers analytics, which will get rid of false alarms and lets one security personnel review multiple cameras easily anywhere in the world. Additionally, these can transmit via satellite signal as well as cellular. Just obviously with satellite it does cost a bit more. Well, I'm not going to take up too much more of your time, so all this data can be exported into an owner's company enterprise system if they already have one. It takes a matter of days, not months, and as we've got rid of paper with the mobile operation system, we have actually searchable, tangible data that can always be found at a later date. Essentially, anything that has either a coordinate or a web link, we can bring into our system. An example of one project we're working on right now is tying into a contractor's telemetry that they've already utilized on their equipment for asset tracking. We're going to have a project-specific asset list, and their goal is to lower their trucking costs and as well as track production remotely. Stated before, we've developed an easy-to-use visual interface that can be used for the entire life of a project, from estimation, project pre-construction, record of conditions, planning to turnover package. We have one constant system that tracks everything that doesn't require additional staff or client to use. With our search parameters, we can look for searchable fields that may track UPIs that have been approved and might be missed on the field, might have been missed prior to that. I'd really like to thank you for your time and taking to watch our webinar. Please feel free to contact me at any time. Thanks a lot and have a great day.